All right, so welcome to this class again, as I said, and we are going to be looking at set notation. So we have questions that will help us to understand what set interval notation. We're looking at set interval what notation. So first of all, what is this set interval notation? So set interval notation is just a shorthand way of what representing continuous numbers. So an example. So in here we'll talk a lot about the what about the real numbers. So these real numbers represented that is from negative infinity to what positive what infinity. So you understand that continuous numbers, for example, in between numbers, let's say if you have 0 and 1, the numbers that are in between here are a lot. You have 0 0.1, 0 0.12, 0.0001. Like there are a lot of what numbers that are there. So because we cannot list them, or we use set interval notation to what to represent these numbers. So unlike in the first case, like maybe in your secondary school, what you're doing, you're mostly listing the numbers of that set or the elements that are in that set. But now, because we cannot list every element in that set, we represent it by what? By an interval. So now, in this interval, we have the open brackets like this. So the open bracket, what it means that the number, so I represent, let's say there's A and there's B there. So what this means is the letter A here, or this element A, is not part of your set. So if it's open, this bracket here, this parenthesis, represents an open what? An open interval. So it means here it's what? This set, this element A is not part of what? Of the set. And the same way you see this B here, it would mean it's not part of the set. Then we have these square brackets here. You have A and what? And B, like that. So this here would mean that A and B are part of your what? Are part of your interval. So A and B would mean they're part of your interval. Then when you see that, maybe on one side you have A and on the other side you have B like that. So here it just means A is not in the what? In the set, whilst B is what? Is part of the set. So the last number there, so the set interval notation will give you your starting point and your end point. And then these brackets will help you identify whether that number is part of your set or it is not what? Part of your set. So that's what the set interval notation will be what will be doing. Okay, so now let us move on. These questions, we get to answer these questions that are here. So these questions are the ones that will help us to just understand what we've said here. So they're saying use the combination of the brackets, these, and the square brackets to write the what? To write the sets. So we have the first one, A there. So on A, you have, so this here has been given in set Peter notation. So it says it's a set of OX such that X is a member of what? The real numbers. So this R here just says real numbers, such that X is in between. So X is in between what? 7 and 13. But here you see where there is 7, where there's 7, there's a less than or equal to symbol. So it means that 7 is part of what? Is part of my set. So another thing that we can mention is this. So when you see less than or equal to like this, or you see greater than or equal to like this, so the equivalent of this is the what? The square brackets, this square bracket like that. Then if you see strictly less than and then greater than, the equivalent are the what? The parentheses like that. So this is how we are going to what? To use this. Okay, so now here they want us to write this set using that. So where there's 7, we see that there's what? Less than or equal to. So we are going to put what? A closed bracket, and we put 7. So that means 7 is part of what? Part of our interval, or part of our what? Our set. And then comma, so you separate them by a comma. That's separating the starting point and the ending point. But this here does not mean that 7 and the number that we'll put next is going to mean that there are only 2 numbers. No, it even includes all the numbers that are in between that interval which we've made. And then here you see there's 13. So 13, there's only less than here. So it's going to be 13, and then I put an open what? Open bracket like that. Okay, So as I said, if there's any question, just feel free to unmute yourself and ask. So now the next one says you have B there. It's saying negative what? Negative 4, and then x. So x is in between negative 4 and what? And 13. So at negative 4 there's less than, so it's going to be open. So negative 4, comma. Then at 13 there's a an equal to sign, less than or equal to there. So it means that at 13 it's going to be what? To be closed like that. Okay, so C, let's now move on to C. So C here has been given like this. So C, you see it's saying that X is a member of what? Of the real number such that it's in between. So negative 6 and 3x there and what? 12. So now what we're representing an interval of what? Of the set X and not of what? 3x. So what you do here, you just what? Divide the 3 throughout. So you divide 3 there, divide 3 there, and divide 3 there. And then you just have this is going to be, there you get negative 2, then you get x, and then 3 into what? Into 12 just gives us 4. So this here is what we have to write. And you see there's less than, strictly less than. So it means you're going to have what? Open what? Parentheses. So you have negative 2, comma what? Comma 4, like that. Okay, and then the next one, you have D there. So D here is given by, so you see x is in what? A real number such that it starts negative what? 6, and then to what? To 4. But there's negative 2 in between there. So let us do that one. So that will be negative 6, and then less than or equal to, that's negative 2x, and then less than or equal to what? To 4. So here it means you have to what? Divide by the what? Negative 2. So you divide by negative 2 here, divide by negative 2 here, divide by what? Negative 2 here. So now, when you divide by a negative sign, the signs, these, the less than signs that you're seeing there are going to what? Are going to flip. So here when we divide, you get what? Positive what? 3. So this sign will change from less than to what? Greater than. So greater than or equal to, like that. And then in between you get what? X. And this one here will also change to less than what? Equal to. And then there you have a what? You have a negative what? A negative 2. So when you divide by the negative like that, the sign is going to what? Is going to change. So this means that x is in between what? 3 and what? Negative 2. Or you can write this as that is negative what? This here is equivalent to saying negative 2. If I want to use the same less than symbols, I'll say it's less than or equal to x there, less than or equal to what? To 3, like that. So this is what it means here. So when we're writing set interval notation, you always start, the number that is going to be to your left has to be the smaller one. And then the number that is going to be your right in your interval has to be the what? The bigger number. So now, in this case, the smaller number, we know that negative 2 is smaller than 3. So meaning when writing this now in interval notation, you have, it will have a square bracket since there's equal to there. So it will be negative what? 2, comma, 3, and then you close like that. So you always make sure that the bigger number is what is to your right, and then the smaller number is the one you started with to your what? To your left, like that. Okay, so this is how you do it.
Put the other numbers that are in between the two intervals that you're given, or it's a match just put the two numbers.
Okay, your mic is unstable. I'm unable to get your question.
Oh, I'm saying, you see, is it that you have to just put two numbers, or suppose you put the other numbers that are in between? For example, it's 7 and 13.
Okay, you can mute your mic. All right, thank you. So I think I'm not the only one who had like I don't know if it's your mouthpiece, but when you switch on your mic, it's just making a noise and you can barely get anywhere out of it. So maybe you could write your question in the chat, and then I'll take a look at it, or I can answer it maybe along the way. Yeah. So but then the little that I got, maybe I don't know if you're asking about listing all the numbers here. So we are saying in this interval, when it comes to this interval notation, is there are a lot of numbers in between here because we're talking of real numbers. So real numbers, what does real numbers consist of? They consist of natural numbers. They consist of the integers, that is meaning the negative and positive integers. They consist of rational numbers. They consist of what? Irrational numbers. So there are a lot. So the rational numbers, those that we can express in the form a over b, like that, a over b, that is maybe a fraction, like half you have there. And you have numbers like square roots, like square root of 2. They are part of that interval in between that will be there. So you can't list all the numbers. So we just list the starting point and the what and the ending point of what of the set, and then we say all the numbers that are what that are in between. So you just list like that, and you just separate by a comma. So this here means a lot of numbers that are here. Actually, we can't even exhaust them. They are infinite that are here. Yeah. So maybe you type it and then I'll take a look at it as we are going. But I couldn't get anything. And I'm sure I'm not the only one. All right, let's move on to the next concept. So the next concept is saying write the following in what? In set Peter notation. Now, this time we are writing from set Peter notation to interval. Now they've given us an interval notation, then we write to what? Set Peter notation. So for the first one, we're just going to have this here is the set of what? Where x is what? So now we said the underlining set which we are looking at is a set of what? Real numbers. So this x is going to belong to the what? Real numbers. Because here, as you see, as we progress, that we are moving towards the what? The number line, the real number what? Number line. So, and of course, as I mentioned, that those numbers which make up the real numbers, you have a lot of numbers, the irrational numbers, the rational numbers, the natural numbers, the integers, they all make up what? Real numbers. So here you say x, a member of real numbers, such that the first one you're saying it's negative. Here you have -1, and then that side you have 1. So x is in between what? -1 and 1. And then you see there are open parentheses. So it's going to be strictly what? Less than. So here you have -1, less than, because it's open. And then you have what? You have, you're going to have here x, and then less than what? Less than 1. Okay. So this is how it's going to be. All right, so I've seen the question saying, right, two numbers. Okay. So I think we've answered your question. So your question was, yeah, we just have to write those numbers, and you can't list them actually. There are a lot of numbers, cause. Okay, so this is how you'd write them in set PIDA what? Set PIDA notation here. So we do the same for the next one. B, you just have the set of OX such that the set of OX that is in R, of course. And then you see here, there's -6. So -6, and then there's what? An open bracket. So less than. And then X comes here. And then there you have what? You have 3. So 3, there's a what? There's a square bracket. So it will be less than or equal to, then 3 there you write. Then you close like that. Okay, then our C, you have that is going to be X, remember of R, such that there it is closed here at -4. So you have -4. It's closed, so we use what? Less than or equal to. Less than or equal to there. And X is there, it's open, so you have strictly less than 1. Okay, and then these two here now that we have, this is where we're going to write to list out the different form. So here, what you just say for this one, you have D, you say X is a member of the real numbers such that, so here, what this means, you have 3, comma, going all the way to what? To positive infinity. Another thing that I forgot to mention is, when it comes to infinity, so infinity is not a fixed number. So it's not a fixed number. You don't know what it is, because numbers continue to go forever and ever and ever. So we don't know what this point is exactly. So you can never have a square bracket. So when it comes to this here is wrong. If somebody was ever to write this here is wrong. This can never happen because we don't know what infinity is. So we just always represent it by what? An open bracket. Okay, then when we have such such a set that has been given like this one here. So let me erase this. So such a set that has been given like this one here. They are saying this here is just those numbers that are starting what? 3 going to what? Going to infinity. But 3 here at 3, it's open. So meaning 3 is not part of your what? Part of your set. So how you would write this, you just say x is what? Greater than 3. So all numbers that are greater than 3, they're a lot. That's why there's infinity there. You'd write x greater than 3. That's all. This is how you'd what? You have this one. And then E here, you have set of OX, member of the real numbers, such that they're telling you here negative infinity. So negative infinity is the same also. It doesn't have what? A fixed point. But then where are we starting? You're starting X at what? At 1. So from 1, everything going down, including 1 itself. So here you're just saying what? You're saying X is less than or equal to what? To 1. So X is less than or equal to 1, like that. That's how you'd what? You'd write this, and then you close, like that. Okay, is there any question? All right, so there's no question. Let's move on to the what? To the next one. So next here, they're telling us now, here we're going to move to a concept of now displaying on the what? Real line. We've now reached the number line. So display each of the following intervals on the what? On the real line. So first of all, the real line, which you've seen before, is just a line like that going there to there. So this here is the what? The real line. Where you're saying this one, left side is pointing to what? Negative infinity. The other side, positive what? Positive infinity. In fact, we can even answer this last question there in advance. So this here, negative infinity to infinity. That is the real line, because this here is the definition of what real numbers are, the last one there. So we've already answered E. Just writing this here is E. So this is how it would what it would be. But then let's go now to A. So A is telling us that A is equal to, you have open there, negative 10, comma, then 10, and then it's closed there. So here, they are telling you all the numbers from negative 10 towards to 10. But then here it's open, at then 10 is what is part of the set. The 10, the negative 10 is not there, but the 10 is part of the set. So how do you write this one? So I'll just list here. I'll say, okay, if I have, maybe my negative 10 is here. And then I have my what? My 10 there. So at negative 10, it's open. So you're going to write an open circle there. And then you write a line all the way towards to 10. And then 10 there, you shade in the what? The circle. Since 10 is part of the interval, so you shade in the what? Circle. So this here is what is going to what? Represent those numbers there. This part here is, so everything from, so 0 here at negative 10, we leave it open because 10 it's open there. It's not, meaning 10 is not in my set. While on the other side, the 10 there is going to be what? Be part of your what? The set. Okay, other textbooks, you can see that they even just go ahead and shade this part. But even if you don't, you'd still have what represented it like that, just by that line. You still have, would have what represented it. Okay, let's do part B there. So part B, so I want to use this same line here. So if you want, you can actually write a lot of numbers, like you write, so here, okay, for example, this next one, I have 2 and I want to say I have 11 there. But yeah, you can list other numbers. That is, there's 1 before 2, there's maybe 3 here, there's 4, there's, yeah, all those numbers, but it won't add anything to it, because when you're going to when you're going to draw this, what they're interested in is to see where you have your open circle or where you have your what? Your closed circle. So to keep it just simple, just write the numbers that they want there, those endpoints. So you have, so here you see it's closed, 2 there, and at 11, it's closed. So it means at 2 I'll write and I'll shade in, write a line, and at 11 I what? Shade in, just like that. Then I do the next one. So next one, you have, let's fix this here. Okay, so The next there, you just have -1. So -1 here, I say 5 there. So here it's open, and at 5 it's what? Closed, like that. Okay, just easy like that. Yes, is that a question? Okay, so yes, you can ask your question.
Okay, so my question is, those figures A, B, C, D, E, they're supposed to be on the same number line or each one separate?
Oh, okay, okay. So for this one, you just say display each of the following on a number line. So you can display them on a different versus number lines. Yeah, they usually want you to display on a different number lines, not on one number line. Unless if they give you one question where you will see in the next part, then that would be a possibility of you putting it on one number line. But like this, part A is a different line, different line, different line. So I'm just using one line because I don't want to draw, keep on, I rub, I draw, I rub, I draw. So I'm just writing one. Okay. So we can continue, right?
Yes, you can continue.
Okay. All right. So here then we are saying that the next one, D. So D, let's say we have our 0 here. 0 is there, and at 0 it is closed. It's like this and going to infinity. So here you what? You shade in like that. And then you write an arrow going towards your positive infinity, which is this side. So just write an arrow like this. So this here is going towards to show that I'm going towards what? Going towards positive infinity like that. So that there means this set. So all the numbers from 0 to positive infinity, those are a lot of numbers. So like that. And then the other one, this R we had is it's the one which we had shaded. We had started started with that from negative infinity to infinity is just this real line in red. Yeah, just that line. That's all. So in case you missed like that there. That is this last part. Okay, so let's move on now to look at how do we apply. Now we've learned how to draw. We've learned what we need to do when we're writing our set interval, how we shade in, and like all that. Now let's apply that to what to these questions. So they're saying let R be the universal what? Universal set. And there's listing A is that, B has been given there, C also has been given. Illustrate each of the following sets on the number line, hence find the what? The following what sets. So you should find this and all those things there, we must find them. Okay, so first of all, I'll just illustrate all these like these sets which have been given on what? On this number line. So A has been given as -6 to 1, close. And then you have B there, it's closed on both sides. And then you have what? C there. So C is in saltpeter notation, so we can write it in interval notation. So interval notation there, it's saying negative what? -9 this side, so it's closed since there's less than or equal to, so -9, and then you have 8 there, but it's less than, so it will be open. So this is my what? My C. So they've told me that my universal set is just the set of what? Real numbers. Let R be the universal set. And that there is just this from negative infinity to what? To infinity, like that. This is my R, or my universal set. And then my set A. My set A you have, yes. Is that a question?
Yes, sorry. Just got missed on the how you found C.
Oh,
How
okay.
did you
Okay.
find C?
All right. So how we found C? So C has been given. It says X, a member of real number such that it's in between -9 less than or equal to X less than then 8 and then like that. So what we said, this here is saltpeter notation, but then we want to write it in what? Interval notation. And we said that here, this value, this symbol here that you see, it's less than or equal to. So this less than or equal to is equivalent to what? To this parenthesis, which is the square bracket, which means that that end number, the -9, is part of what? The set C. And then this other side, it is just less than. So when you see less than symbol, you have to think of open. Less than, open. So here 8, we open like that, meaning the 8 is not part of the set like that. It's just showing us a demarcation, but it's not in the set itself. So that's how we move from there. So when you always see this less than or equal to, or you see greater than or equal to, so for greater than or equal to, it will be like this. Then this other side, you have it to be what? This, like that. So that's what they are going to that they're going to mean. Okay. So that's how we got it. I hope it's clear now. All right, so now let's continue with this. So we said our A, that's -6. So let's say you have a -6 there, and you have maybe your 1 here. So that set it's open at -6. So here to there, oh, it's open at -6. So open there, and then it's closed at what? 1. And then we have the set B, it's 0 to 5. So 0 there, and then let's say we have our 5 there. So it is closed on both sides. So 0, and there it is what? Closed. So, and then what next? The other thing, this other set, -9. So -9, let's say -9 is there. So -9 to what? To 8. So let's say 8 is there. So from there, it is closed at -9. So we shade in all the way to what? To 8, it is open. So these are the 3 sets. This is how they would look. But then our interest now, the first one is to find the set difference between A and what? And C. So set difference between A and C. So this here is equivalent or is the same as us writing A intersection C what? Complement. A intersection C complement. Okay, so now just to mention this, in case the video cuts, just rejoin using the same link that we continue and finish up these questions. Okay, so this is what we want to find. So our set A we have, then the question is, do we have our set what? Our set C complements. Do we have that C complement? So by definition, what does complement mean? The complement of a set are all the elements that are not in that set, but they sit in the universal set. They are not in that set, but they are in the what? Universal set. So now, our set C, this one which is in red here, you see this in red, that's our set C. So our set C has 9 all the way to 8, but 8 is not part of it. So the complement is going to start from here. So complement to be open at what? At 9. So meaning 9 will not be in the what? In the complement, because it's in what? It's in C. So it will not be in the complement of C. Then all the way to what? This side negative what? Infinity. And then on this other side, 8 is actually what? Not in C. So if it's not in C, it will be in what? C complement. So it will be what? Shaded in there at what? At 8, and then goes like this. So this here is my C complement. So in short, C complement is going to be a union of two what? Two sets. That is from negative infinity. It's open. It's always going to be open when you talk of negative infinity there, comma, and then to what? To -9. And then it is what? Open at -9. Then union here at what? At 8, it is closed. So 8, I close. And then where else? All the way to what? Positive infinity, then I close. So this here is what is going to be what? My C complement. So that's my C complement. Now, they're just telling me intersect. Intersect your A and your what? Your C complement. Intersect the A and the C complement. So in short, find what is common between your what? Your C and your what? Your A. I mean, find what is common between your what? Your A and your C complement. So I will raise here. Let me erase all this here, and then let me just sketch my A and my what? My C complement. So C complement, we said C complement there is this part here open all the way to that side. And then you have what? You have this part here closed all the way to what? Positive there. So now here, next, let me sketch my what? My A. So my A was given, A is open here, and then it is closed at what? At 1 there, which is like that. So now here, intersection means the common parts. So those that are overlapping, do you see any parts that are overlapping in these sketches that we've made? No, there's no part which is overlapping. So it means this A intersect C complement is actually what? Empty. Is actually what? Empty. So from this sketch here, we can conclude that the answer to this A minus C is just the empty set, because we found that there is no intersection there. There's actually no what? Intersection. Okay, is there any question before we move on to the next part?
I've got a question.
Yes.
Since A intersection C squared, for example, if we use like De Morgan rule, isn't that A intersection C equal to A?
We said, you're saying which part? You said C?
The
Can
one
you?
we are from answering.
Yes, the one from answering.
A,
Uh-huh.
yes, A intersection C complement.
Yes, A
If
intersection
we,
C complement. Yes.
yes, if we use the De Morgan rule, is it not going to give us A? Because A intersection C complement is equal to A, isn't it?
No. So A intersection C complement. Look at your C complement here. What is your C complement?
Okay.
This here is your C complement, right? And then we've even put it
Yeah.
here in red. You look at it, right? And then look at your set A
Yeah.
now. Your set A is here, negative what? 6 and the 1 there. Now, intersection means what? It means the common parts. Right? Which ones are common in both sets?
Yeah.
And what numbers are in both sets there? So you see here that these numbers here in the C complement, that's why it's a union of two sets. So any numbers that are here, in between here, that are in between, let me rub here first. Let me rub the A again. So in short, what this means is anything here in between is not in the C complement. You understand, right?
Yeah.
So now our set
Yeah, I
A,
got it.
yes. So our set A, we wrote it's open there and it's closed there, and we see it's in between those there. So they are not intersecting with the set what? C complement. They don't have any common elements. Thus, we cannot say that we are going to land at A only. No. So we land to the what? Empty set. You get now?
Okay, I got it.
Okay, all right. Yeah, welcome. So let's move on now to the next one. So this link is going to close. Just rejoin using the same link, and we continue and keep on enjoying this class. Let's finish up now this next question that is there. I'm going to wrap this. I wrap this here. Okay. So okay, so we have this question here, B. That is B complement. Okay, so we said the next here we have B complement, intersection, C, and then the complement. So the one who was earlier asking about De Morgan's law, this is where it comes to play. So this here, by De Morgan's law, we're just going to get, if we distribute this complement here, it will just give us the complement. So you know that B complement just gives you B. So you get B here. And that C sign of intersection will change from the intersection to what? To union. And then there you have your C what? C complement. Okay. So this is what you're going to do. So now we already know what our C complement is because we found it before. We found the C complement to be, that is negative infinity to, that is 9. And then there it is open at 9, union. And then you have what? It's closed at 8, and then all the way to what? Positive infinity. That is my what? My C complement. And then our B, what is our B? So let's plot first our C complement. So from here it's open to that side. And then there it's closed to that side. Then my B. So my B is B is just 0 to what? 0 to 5. So 0 closed, there closed. Now union means that that element is either in that set or the other one or in both of the sets. That's what it means. So now when it comes to union, just think about you bringing everything together, like join everything to what? Together. So I'm just going to join all these sets into what? One set. So B union C is going to be, so my B union C is just going to be, that is going to be the set from negative infinity to what? Negative 9, open there, union. Then this part here, the one which is in between, that is here, from what? 0 to what? To 5, and then I close. And then union what? That is from 8. It has a square bracket at 8. And then all the way to what? Positive infinity. So this here is going to be what? Is going to be this part, second part, which is just B union C what? Complement. It's going to be bringing all the three sets to what? Together. Okay. Let's move on to this next one here. So what is the next one going to give us? So let me erase. Okay, so the next one we have, so you have this here. So that one there, what is it going to be? So you have there, you can write here, you close it there like that. Or again, I said if you have any question at any point, you have to just unmute and ask. So we said C, set difference of what? Of A. Yes, you can ask.
Sorry, I was just disconnected from the meeting. I've been left out on B. So if you maybe can go back or
Okay, no problem. So B, what we said is you have B complement, then intersection C, and then the what? The complement there. So here, this is where you what? You apply that De Morgan's law, where you are what? You distribute this complement inside, but then that symbol flips from, it changes from intersection to what? Union. So now B complement, then there's that complement. He said B complement is going to what? Give you B. So you get B there. Then this changes from intersection to what? Union. And then there C what? C complement. Like that is going to come there. So this is what we are finding in short. So earlier we found this C complement, which is from negative infinity to what? To 9. And then it is open at 9. Union from what? That is the other part, closed at 8, and then positive what? Infinity. So this is my C complement. C complement. Then B, I have already been given. It's from 0 to what? To 5. So there, if I was to shade my B, it's there from 0 shaded in to there. And then my C complement, it is shaded there, then to what? To that side. And then here open to that side. So now they're saying union. Union means bring everything together. Bring those two. They are now, two sets together. The set B and the set C complement. Bring them together. So to write them together, just say negative infinity to what? Negative 9. And then I close. Then the other part, you see it's here. That is so going to be union. Then you close 0 to what? To 5. And then I close union. Then that side from 8 to what? Positive infinity. So this is how you would do it. Okay. Let's move on now to part C. Unless there's a question on this one. All right. So there's no question. So part C is saying set difference of A, of C, and what? And A intersect what? Intersect B. So set difference of the two. So so now you're looking at the one which is inside the intersection, the one which is what? Outside there. So what is inside, you can think of it as C intersect what? A complement, like that. And then you're intersecting with what? With B. So let's handle this first, which is inside. C intersect A complement. So our C we have already, it's there. Our A complement. So A complement, let's find A complement here. Yes. Go ahead, you can ask a question.
Yeah, even me, I've got a question there.
Yes.
Isn't that because since we have got C intersection A complement, then close bracket intersection B complement, isn't so? Which means B is not going to be distributed with C and A complement, since we have got two same sign, intersection and intersection.
Okay. So thank you. Here you have intersection and there you have intersection, right? So when you have
Yes,
intersection there, remember there's that law which you learned, the associative law, right?
yes,
Yes. So associative law says if you want, you could have said, you say C, you say you get the intersection like this. You maybe get C intersect what? B, right? You could have done that.
yes.
Then you intersect it with C. Or the same way which we are, the same approach which we're about to do, where we say C intersect what? A complement, and then we intersect it with what? With C. So what that just tells you is handle this first part, then you intersect it with what? The other what? The other part. Or if you wanted, you would have done this and then you do that. It's just the same. It's what? It's associative. Yeah. So distribution, you see, distribution is going to work when maybe you have what? You have a union somewhere. That's when you can distribute it like that. So in cases like, for example, if you had, if if you have A, then you have union, and then you have C, and then intersection A complement. So distribution would be saying you say A union what? C, and then
Yeah, C,
intersection, then yeah, you have A union what? A complement.
A complement.
Yeah, so this will be distribution. Where you know this A union C, this A union A complement is just a universal set, and then intersection A union what? C. Anything you intersect with a universal set is that actual set. So you'd remain with A what? Union C. And then you just sketch this one here. So,
I got it.
oh, you got it, right?
Yeah, because I was confused between so it's like distribution we're doing with two different signs.
Yes.
Then okay, I got it now. Thank you.
All right, you're welcome. I saw
Thank
another hand. You still have a question? The other person who raised their hand. Okay, so there's no question. So let's move on. So you have C intersection A complement. C intersection A complement. So now what are we going to do here? So C intersection A complement. So we are looking at our A complement, that we need to find the A complement here. So our A first, our A is open here at 6, and then it's going all the way to 1, and it's closed at 1. So the complement of that is going to be everything that is not in there but is in the universal set, which is going to mean here we will close it and then it goes that way. There it will be open and it goes that way. So in short, A complement is going to be, this A complement is just going to be equal to negative infinity and then all the way to what? 6, and it will be closed at 6. Then union, you have it open at 1 and then all the way to what? Positive infinity. So this is your A. This is your A complement. Yes. Okay. You can ask. Okay, so maybe the person who's trying to speak, you can maybe text in the chat because your mic is really unstable and we can't get anything. The other person who's raised their hand, that is it Joe? Joe, you can ask your question.
Yes, sir. My network has been tripping from the time you started solving the second questions there. So I was kindly asking if you could repeat.
The second, which second question? Part C or like which part B?
The one, yes, part B to see there.
Okay, so we'll just continue with C. For part B, I'll send a recorded class, like the class will be recorded, so you can just watch through it. But I'm sure you get the concept for part C. Okay. Yes, the person who's raised their hand can go on. can ask your question. Okay, it's just saying techno KM4. I don't know, so you can just ask. Yes, the techno. Okay, maybe they no longer have the question. The question. So let's move on. So here, this part in blue is our A complement. You say that's our A complement. Now, that is our A complement. What are we doing? We're intersecting it with what we see. So what is C? C is from negative what? 9. It's closed here at negative 9. And then it goes all the way to what? To 8. And it's open at what? At 8. There at 8 is going to be open. Okay, so now intersection. Yes, you can ask your question.
Oh yes, there on the A complement, that answer. Since our universal set ends at with 9 and 8, why didn't we put negative 9 to negative 6 there?
Oh, okay. So don't get it confused. Here, we said our universal set, saying let R be our universal set. So the universal set of this question is R, which is from negative infinity to what? To infinity. That's hence we've written it that way.
Oh, they've not specified.
Yeah, so it's saying R, let R be the universal set. So they did not specify the set to be maybe from a certain point in number. No, they just said the whole set of what true numbers.
Okay.
All right. So now here next is to find what? The intersecting point. So you see where these lines here and there, you have that point and that point like that. So this line here is going up to infinity like that. So now here, like that and there. So the first part, this part here, what is that here? So there we're going to say that is here at negative 9, it is closed. So at negative 9 will be part of that set. And then here at negative 6, it's closed also. And this negative 6 is in what? Is in this this green set. And this green set, we say that is the set what? That is the set C. So it's in C and it's in A complement. So it's going to be part of the intersection like that. And then union, what other parts intersect? These parts here intersect. Now, here at 1 here, you see that at 1 it is what? At 1 there it is open. So meaning this 1 is not in the set what? Is not in the set A complement. Since it's not there, it can't intersect. So it's going to be what? Open at 1 at 1. So I put open it there. Comma, then here at 8 like that, another point where it's intersecting. This 8 is not in what? Is not in the set C. So it can't be what? In the intersection, even if this 8 is in the complement. It's in A complement, but it's not in what? It's not in this set C because it's open there at C. So it can't be in the intersection. So it's going to be what? Open there also. So this here is my C intersect A complement, which is the first part here. C intersection what? A complement. Okay, now let us write this one and then so I write just this C intersect what? Intersect A complement, which is from closed at negative 9 to 6 closed, and then open there, and then to 8, it is what? Open. So this is this part. Now they're telling us intersection, this intersect what? B. So we intersect it with B. So we're going to write our B. We know our B is what is there from 0. It is closed at 0. So there 0 closed, all the way to what? To 5, and it's closed. So you look at the two intersecting points here. Where are the common elements? Where are they crisscrossing? It's here and there. So these parts here. So now, what is that going to be? So that there is just, you see this part here, where there is 1, it is open. So it will be open at 1. So at 1 there to be open. And then this here at 5, it is what? At 5 there, it is closed. So meaning 5 will be part of the intersection. So I'll intersect at 5 like that. And I would have found my answer there. So that is our final answer. So if you are to sketch it, to write your answer, you just write there negative infinity to infinity, and then there at 1, and then at 5. Open there, and then you close there. That is the answer to what? To this part C here, like that. But of course, you show this step here, and then you write this final answer like that way. Okay, is there any question before we move on to this one and the last one there? Yes, yeah. Yes, Mapaloike.
Yes, so when you are solving a complement, my network cut, so I didn't know how you got these values. Can you just repeat
Okay, so,
just that part? Yeah.
all right. So A complement, A has been given as this one there, from -6 to what? To 1, and it's closed at 1, it's open at 6. Complement means everything outside this here, but is in the what? Universal set. Our universal set is what? Is R there. So we're going to get every point that is outside there. So what is that point? So you see I wrote it here. So here how we found it.
Yes, I see that.
So here we said, since here it is in A it is what? It is open. So meaning when it comes to what? To the complement, it's going to be closed. And then it will be going all the way to what? To negative infinity. So in short, here it's going to be closed, and there it goes that way. And then where is the other point? At 1 there, it's going to be what? To be open, and it's going that way to infinity. So let me, okay, just in case you're not what's this, let me just write out. So the set A is open here, and then, okay, you can mute your mic. All right, so there, and then here it's closed. So this is our set A. So the complement, everything outside this part is in the universal set. So it will mean, since here at 6 it's open, so the complement of A, it will be what? Closed. And then it goes where? All the way to what? Negative infinity, since this is the part which is in the universal set. And then there, since it's closed here, to be open, and then all the way to what? To infinity. So that's how you get the what? The complement there of A. Then of course we used that, we intersected it with C. After intersecting with C, we found an answer and intersected it with B, which in the final end gave us this part here. All right. Just in case you missed that one, I hope you get it on the next one. Yes, you can ask your question.
Yes, there on the final answer 1,5. Why don't we put the other three, like where A and B and C intersected?
Okay, so let me bring back again. So here, this is what we have. Now, intersection, what intersection means is the ones that are common, right? So when we had drawn here, I've even forgotten what we had drawn to be our C intersect A complement. But yes, so the drawing that we had something like, you had this part, there was something, and then all the way to like 8. I don't know, and there was another set here on top, like that, which was closed here.
Yes.
And then we found the intersection, like this part here. This is where they have common elements. So intersection just means those common elements. That's the reason why we just got the ones that were common, because on this other side, it had no intersection. It had no common element. So you just get what is common, and that's what you write there. We only write that way,
So
like if it was union, remember like the one which was union there, that's why we wrote all those sets like that.
so that statement simply means that C and intersection B only, excluding A.
Which one?
The same question C.
Okay, so question C
It simply
here.
means,
Okay,
yes.
so yes, you can say what you think.
It's like on question C, the question, does it simply means that you're only intersecting with C and B only?
Okay, so intersecting with C and B only.
Yes, it's A complement.
Okay, so the A complement also was intersected. Remember here we started with C and we started with the A complement. So we found the intersection of these two and then we intersected it with B. So if you had started with, you could also have done where you say, we said this is associative. So if you say you intersect B, A, B, and C, and then you'd still have to intersect it with what? A complement. Also, if you start with B intersect, I mean A complement intersect B, you still have to what? Intersect it with C. That's what the associative law tells us, that we can do it in those directions. But we chose first to intersect C and A, and then the outcome, you intersected it with what? With B. Yeah.
Okay.
All right.
Thank you.
Sure, you're welcome. Do I have any other question before I move on to part D? Okay, so part D, very easy. They're just telling us to find the complement of what? Of B. So B is closed there, and then it is closed there. By now, I think you've seen it so many times. So the complement to be open there goes to the other side. Open there goes to the other side. Just like that, you would have what? Written your set B. So writing it separate there, I have like that. Then I write 0, 5, there open goes like that, and then open there goes that way. So that is going to be the B what? Complement. Okay, let us do the last question now. So here, our last question is on this part. There will be one more which has a different universal set. So they're telling you A intersect B complement. So first, it's good just to find A intersect what? B. So what is my A intersect B? So I write my A. So my A, it is open there and it is closed at 1. Then my B, it is what? Closed there and it is closed at 5. So where do these two intersect? So they intersect at these parts, there and here. That's where they intersect, these two parts here. This is where they what? They intersect. So the intersection there is just going to be closed at 0 and then closed at what? At 1, like that. So these here are what is common in both of the elements. So this is A intersect B. So A intersect B is just 0, 1. All the numbers in between 0 and 1, they're actually a lot, infinitely many. So now the complement of that. So if I was to sketch that alone, you just have this here and that. So the complement, everything outside this is going to be what? Open there, going this side, open there, going what? The other side there. So in short, you just get that your answer for the complement. So for this same set, which is A intersect B complement, is going to, the complement is outside. This here is just equal to, what is it equal to? That is negative what? 9 to 0. Not negative 9, negative infinity here. Negative infinity to what? 0, it is open, then union there at 1 all the way to what? Positive infinity, like that. So, of course, if you sketch it separately, it's just not going to have this part. Like it will be this 0 going this way, 1 going that way, and then the union there. So you're bringing what? These two sets together, that part and that part. Okay, do I have any questions? Yes, you can ask a question.
My question is, why didn't you distribute the complement first? Like we use the other method.
Well,
Why did you just go direct to solving?
All right. Let's use the other method. The other method, you have A intersect B, right? And then complement there. The Morgan's law tells you you're just going to get A complement, union B complement. And then you bring these together. Now, you're telling me why I didn't use what? In mathematics like this here, you use what is going to be what? To be faster and easier for you. So first, this one means you have to get A complement and what? B complement. So my A complement, what is A complement? Everything outside that interval. So the A complement is going to be closed there and it's going that way. And then 1 here, it's going to be open going that way. So that is my A complement. My B complement is going to be B complement. It's going to be open at what? At 0, going that way. And then it's going to be what? It's going to be open at 5, going what? Going that way. So now what does union say? Union says bring everything together into one set. So in short, you're going to combine this here. This part combines, this part here, what? Combines, like that. So you see that this here is, this blue arrow is swallowing the what? Like a green arrow. And this green arrow is swallowing the what? That blue arrow. So what you just remain with is you have that blue arrow on top like that, which is going from what? From 0, like that. So that your set is going to be negative infinity there, infinity. Then you have 0. And then this green arrow which is down, that is 1, and it's open at 1, and like that. And you still get the what? The same answer, which is from negative infinity, comma, 0, open, open, and then union there, 1, open to what? Infinity, open. And you will find your answer like that. So whether you use that one, you use this one, you still get the same what? Still get the same answer. So use what is going to be what? To be faster, and which is going to work best for you. Is it understood? Okay.
Yes, thank you.
All right, you're welcome. Let's take a look at these just two last part of the questions. So in this one, they tell you let x be equal to that is negative 10, and 10 is negative 10 is included in our set to what? To 10. And they're saying this be the universal set. So we now have a specific what? Universal set, which is, I draw it here at you have it at negative 10 there. So negative 10, it is closed. So there we say our negative 10. Then at 10, it is open. So there we say our 10. So this is our universal set. And then we have been given what? The set A, which is closed at negative 6 and closed at 1, and B, open at 0, closed at 5, and C, open at negative 7 and closed, open at negative 4 and closed at 7. These, they're saying they're subsets, which they are in here. And they're telling us to find and illustrate the following. So let us find C, A, and then what? Intersect what? Intersect B, like that. So actually, this is the same thing that we did before, where we can say this is just going to be C intersection what? A complement, and then intersect what? B. So let's find this. We have our C. Let's find our A what? Complement, and find the intersection. So our A complement, so A has been given, that is from negative what? 6 to what? To 1, and it is closed on both sides. So as we open, we say open it there, and it goes all the way to what? To negative 10 there. Negative 10, and it will be closed at negative 10. And then union, to go union, what other side? The other side, it opens up, and then it will be what? 1 all the way to what? The last point there, which is 10, and it is open at 10. So that will be your what? Your complement. So in short, if I write it here, so if I have negative 6 there, and I have 1 there. So this here is my set A, like that. So the complement is going to be open there, goes, and then it closes there. Since negative 10 is in the universal set, so it can be part of the complement. And there we open, and there we open. So here at 10, it can't be 10 can't be part of what? Can't be part of the complement of what? Of A, since it's not even in the universal set because it's open there. So this is what you would get. So this here in blue there that has remained is our A what? A complement. Then our C, what is our C? Our C we have here, that is at negative 4. So I write negative 4, let's say negative 4 is somewhere there. And then to what? To 7. So let's say our 7 is there. So that is going to be here at -4, it is open, and then I go all the way to what? 7, it is closed. Then they're telling me what parts intersect here. So the intersection here is going to be this part and this part here. This is where they intersect. They have common elements there. Those elements there are overlapping. So intersection, you can think of it as what? Overlapping. So at 1 here, but 1 is open, so it won't be in the intersection. So it will be open there. And then at 7, it's closed. So 7 will be part of that intersection. So 7 there, we are going to close. So this here is our C intersect A complement. That's our C intersect what? A complement. So let me write it here. So our C, so they are open and all the way to 7, then we close. So this here is our C intersect A complement. Then they're just telling you intersect it with what? With B. So I'm going to sketch and write my B here. So my B from 0, so let's say we have 0 here and we have 5 somewhere here. So it is open at 0 and all the way to what? To 5, and it's closed at 5. Then they're telling you what is the intersection. So what are the common elements? So the common elements are there and there. So these parts here are what is common. So here at 1, 1 is not in the set. It is not in this blue set here, which is the C intersect A complement. So it can't be in the intersection. So it will be open at there 1, and then at 5 there it is closed. So it will be what? It will intersect at 5. Hence, this here is just going to give us 1, what? 5, and closed at 5. Where if you just sketch it alone, you have that this here is going to be there, closed here, -10, open there at 10, and then you have your 1, and then you have your 5. So open, then closed. So this here is your answer. All right, let's do the last question. So now the last question here just says B union C complement and then complement. So you can distribute this complement. It's going to be B complement. This sign changes from what? Union to what? Intersection. De Morgan's law. And then this C complement is just going to be what? C. So you need your B complement and intersect it with C. So what is our B first of all? So our B is here. It's from 0 to what? To 5. And it's closed at 5. That's our B. Then what is our what? Our C. I mean, what is now going to be what? Our B complement. So everything that is outside this set here. So it will be closed now at what? At 0, and it goes all the way to what? To -10, and it's closed at 10, at -10 also. Then we open here, and it will be open there. So this here is my B complement. So I have a B complement now. Okay, so after having my B complement, now intersect that with C. So C, where is C? So C is from -4, so it's open there at -4, and then it's closed at what? At 7. So where do these intersect? Where do they what? Intersect? So it's this part there, this one, and this part there, they what? They intersect. They have common elements there. So here it's open at -4, so I'll leave it what? Open, and then it's closed at 0. 0 is closed there, and it's in that set, so it's going to be 0 closed. Then union, there it is open at 5, so I leave it open. And then at 7, it's closed, and 7 is in that set, so it's going to intersect that point. So this here is the answer for this second one. That is -44, 0, I close, union, and then I close 5. So it's open here, 5, and then close that side. So this is how it's going to what? To be. Of which you sketch that alone, that is going to just be this side, -10, and then open there, 10, and then this here is going to be -4 to what? To 0. So there, open, and then I close there, and then 5. So 5 there, I open there to what? To 7, then there 7, I would what? Close there. Okay, so this is how you do these questions on interval notation. I don't know if you have any question, but this is where we end with today's class. Do I have any question? Yes, you can ask a question.
Yes, just want to ask about the recorded video. When will you post it?
To be posted today, a little after the class ends. You can I'll share a link to the YouTube channel where you can find it.
Okay. Oh, thank you. All right.
All right. So another thing now that I'm to say is, so we at Discrete Learning will offer math lessons, we offer all the NS courses lessons. You can actually find them on our website. So if you go on your web browser there, just type Discrete Learning. So discretelearning.com, there you find, and then here you just visit there. If you don't have an account, sign up for an account. So you can register there, sign up for an account. The easy steps, just make an account, and then you see it will lead you to this here. So you have different courses. These are our courses that we offer. So mathematics, so you find here, you subscribe to math, you find the videos there. So there are some videos like that we won't be posting on the YouTube channel. So you can only find them on this website here. So when you open there, you find general mathematics. So especially things like all the solutions to the tutorial sheets. You see the tutorial sheets here and assignments, past papers, summarized notes, topic lessons. So here at Discrete Learning, we encourage you to learn at your own pace. So in the topic lessons, when you open here, you find all the topics that you're going to do, from sets, surds, binary, you can be learning at any time. You just go there, you visit there. And then for the tutorial sheets, you can also find them there. So already for those others that have released, we started already solving them. So you can check this out here. So when you go, you choose the university here you belong to. So UNZA, and then here you see there are these folders, 11, 10. You can find your solutions there. So video solutions, you go there, and then you find 2026. Then there's a video there that is fish.